So we've looked at problem solving using visuals, and now we're going to kind of carry that a little bit further and look at how patterning can help us with problem solving. And again, I kind of want you to move away from how you are thinking about things in terms of math and maybe think just a little bit about your own life and where you see patterning there. I think of examples within music, and in music there's all kinds of patterns. There's rhythm, there's choruses that repeat. Certainly in science, when you're looking at people finding cures for things, what they're doing is they're seeing a pattern in how a molecule works, or DNA. If you think about social science and you think about patterns in behavior, if you're a social work major or a psychology major, what you're going to notice is that you will study a person's behavior, and then that will help you know how to help them. I was thinking about some examples as I was working in my yard a couple weeks ago and planting things. What I finally found was there was a good pattern. I would take my flats of flowers and I would place them where I wanted them to go, and then I would go through and I would just dig everything out. And of course, being the math person that I am, as I'm placing them, I kind of had to place them in a symmetrical sort of pattern. But that helped me, instead of just sort of putting something in and then deciding I didn't like it. I set things out and just kind of found a pattern for that. I think about that even like as you're repairing, or if you ever put anything together from IKEA. So you put things together, and while obviously you try to read through all of the instructions, you do see a pattern to how this wheel fit here and now this wheel is going to fit here. Those are all patterns that are helpful, and I would venture to say that all of us use patterns on a daily basis. So maybe as you're beginning this particular section, try to think about those places where you see patterns in your life, how you use them, whether you're a stay-at-home mom and you look at how patterns work with getting kids ready, or if you, within your workplace, you have particular patterns that you use. So think about that, and what we're going to do is we're going to see how that connects to specific number patterns. Mathematics is made of patterns. When we get into looking at solving algebraic equations, if we have a linear equation, which means our x's and our y's are just to the first power, there's a particular way that we go about solving those. If we look at quadratic equations, which will have an x or a y to the second power, there's another way that we solve those. We actually have a formula we can use. If we look at geometry in terms of mathematics, there's tons of patterns in geometry where we look at certain types of triangles and we classify certain things. So math is really made up of a lot of patterns. If we can get our mind thinking about patterns, it's going to make the learning easier. Think about learning our language. When you learn a language, you don't just memorize a bunch of vocabulary. You find patterns in how things sound and how letters, if you put them together, will create this. I still remember from grade school, I before E except after C, and I can tell you every time I'm writing a word that has I and E, I repeat that in my own head. So learning itself, if we can remember the patterns that exist, it really cuts our learning into easy pieces. We don't have to keep learning the same thing over and over and over again. And I think that's one of those things you're going to find throughout this class, is that even though it may not seem obvious, each piece of this class that we do will build, and you will see a pattern of thinking that will really help you as you go through even more difficult concepts. So again, enjoy this piece. Think about patterning. Go out into your yard, see what patterns exist. We're going to talk at some point also about Fibonacci sequence of numbers, which some of you may know and some of you may not know. One of your discussion boards, you're asked to to research Fibonacci and kind of see where his work is in nature, it's pretty cool. And I think it's one of those things that will really help you see math in nature and math just not within the classroom, but really all around us. So get in that mindset of thinking about patterns and creating them and recognizing them and using them to help us solve problems. So in looking at visual problem solving using patterns, we're literally going to be looking at pictures or models of things that we can ultimately turn into mathematical formulas. So if you look at this example that's in your packet, we have this particular model here. And I'm going to ask you to go through a 4-step process. And the steps that I'm asking you to go through are: 1, describe in words what the pattern looks like. The second, build the next building in the sequence. So each of these is called a building. Then we're going to try to describe what the 100th building would look like. So we're going to leap way off this table and try to decide what the 100th might look like. And then we're going to talk about a concept called the nth term, which is generalizing what this pattern is and leads us to a formula mathematically. So a lot of times when people are looking at the patterns, and I tell them in step 1 to try and just make an observation of what it looks like to them. Many times people dismiss that that's an important step in the process. And I personally think it's maybe the most important step in the process. So when I'm looking at this, obviously I see that this is something that builds. My first one is just a simple square or simple tile by itself. I kind of know it has arms and a vertical part and a horizontal part. And if I were to look at this, I would say, so as a math teacher, it kind of looks like a plus sign to me. You may look at this and say it looks like a T. You may look at this and say it looks like a cross. All of those are really good observations about this. So if I were to build the next one, I need to make some observations about that, but I'm guessing that most of you would be able to easily build the next one in this sequence. So we have 1 square, and then our second one, we added a tile in each direction. And then we take this one and we add 1 more tile in each direction. So if I'm looking at this one and I want to know what the next one is, hopefully what you've seen is we can just add another tile in each direction. So this is what my 5th one is going to look like. Okay. And it may take you a while. That was a pretty quick move to get to this one. But so if it takes you a little while, it's okay. But that's what we're trying to do with building the next one. Now it says to try and imagine what the 100th one would look like. And that's a little bit more daunting, okay? So this is where we need to go back and look at what pattern exists in this one. So I go back to my observation that this was a T, all right, or a cross. So what I know about a cross or a T is it does have some sort of a center point. So I'm going to look at that and I'm going to say, this is the center point in building 1. This is my center point right here in building number 2. This is my center piece right here. I'm just kind of moving these apart so we can see really the center of that. In my first building, I don't have anything that goes around. In my second building, I have 1 tile that goes around each of these. In my third building, I have 2 tiles that go around each of these. In my fourth building, I have 3 tile that go around each of these. If I would have kept my 5th one out here, we would have had that center one, and then we would have had 4, 4, 4, 4. So what I'm noticing is that we're building from that center. And if I were just to ask what's the 10th one going to look like, coming back here, if my second one had 1 surrounding it, my third one had 2s surrounding it, my fourth one had 3s surrounding it, I'm going to guess that my 10th one would have 9s surrounding it. It looks to me that for each one of these, where we are with our building, we have 1 less coming off the middle, okay? So now if I'm trying to get to my 100th building, I'm going to imagine that I have 1 center tile. I'll just use this one, 1 center tile, but each of these keeps going. And I'm going to say this one's going to have 99 this way, 99 this way, 99 this way, and 99 this way. So just by recognizing that it was a T shape, and by recognizing how it grew, seeing that pattern, I can really determine all of them. If I'm looking at my 1000th one, I would assume that it has a center die or center tile, 999 going this way, 999 going this way, 999 going this way, and 999 going this way. Okay? So now we've described the 100th. The nth term is, how do I generalize this? So when I'm looking at this one, my first building has 1. My second building has a total of 5. 1 in the center and 1 on each side. My third building has 1 in the center, 2 on each side. So I'm kind of noticing that I have 1 less coming out of each of these. So in other words, we said on our 10th one, we had that center piece, then we had 9, 9, 9, 9. If we say that where we are in our sequence is n, so n is 1 here, n is 2 here, n is 3 here, n is 4 here, how do I describe my figure in terms of n? So what we want to do next is to generalize this to what we call the nth term. And what we've already recognized is that we have a center tile. And then when we were generalizing this, we said for our 100th figure that we had 99, 99, 99, 99. So what we can do is we can recognize this, that with our center block, we then go horizontally in each direction 99, vertically in each direction 99. So if we have our 50th term, we'd be 1 less here. So 49, 49, 49, 49. Okay? What we want to do is we want to generalize this. We want to talk about how this, no matter where we are, we can develop a formula. So what we're going to do is we're going to say that our n is wherever we are in our sequence. So if this were what we call the nth term, we've noticed that each time this piece was 1 less than where we were in our sequence. So we're going to call this n minus 1, this n minus 1, this n minus 1, and this n minus 1. So when I'm looking at the number of tile that I have here, we have our 1 that's in the center, and then we also have 4 parts to this particular sequence, so we have 4 n minus 1s. So with this particular figure, what we've defined is that our nth term, or the formula that will help determine what the value of any of our sequence numbers is given by this formula. If I'm at my 20th term, I have 1 plus 4 times 19. If I'm at my 1000th, I have 1 plus 4 times 999. So the n is referring to where we are in the sequence. This formula defined for us how we then determine how many tile are in each of the buildings in our sequence.